welcome to the session. Now we are going to see about construction of Turing machine which can compute a proper subtraction. So we have proper subtraction in the sense when you're having this m and n as an input. So if this m is greater than n, it should give m minus n the result, and if m is less than or equal to n, it should give the result as 0. So for example, my input is 3 minus 2, it should give 1. If it is vice versa, 2 minus 3, it should give as 0. So or it is, if it is equal, both numbers are equal, it should be given as 0. So for this we have to see this working of Turing machine. So here let m equal to q epsilon tau del q naught b f be the required Turing machine. So before going to for the transition diagram, we will see how the working mechanism will be happen. So for example, if I'm having 1 1 1 and you have this separator, after this we will have this 1, so again you will have this blank symbol. So even before also this tape contains blank symbol also, right? So in between you will have this input string. So for this here 3 and 2. So this is the separator used to identify this is m and this is n. Okay. So initially my tape head is here. So first I have changed 1 is replaced by b, and it move forward direction, so it's the right direction until the blank symbol occurs. Once it sees the blank symbol, it goes to the left direction and change this 1 as blank symbol. So again it going to this leftward left direction until the b it sees b. So once it see the b, it has to go for right direction, and here 1 is again changed to b. So once you change this b, you have to see the equivalent of 1 in the next side, which means in the n part. So it has to go for the next one. So it has to change 1. So until it has to go for b, it has to go for right direction. So once it sees b, it has to go for the left direction and move and replace 1 as b. So again, so for this one have cancelled it, and for this one and for this one have cancelled it and replaced by b. Everything is b. So once it changes is b, so it has to go forward backward and until it encounters b. So once it sees b, it has to go for the right direction, which means I have to replace 1 by b, right? So after that, we will have this go for the right direction, which means until b, you have to go for the right direction. So once the tape head sees this b, it has to go for the left direction, but that leftmost symbol always have this 1. But when it sees 0, you have to make this 0 as 1. So this is the scenario where see here, now my 3 minus 2 will be 1. So this is my answer for this proper subtraction. Okay, so this is the way it has to be worked. So for this we will have this transition diagram. So we have to draw a transition diagram for this. So transition diagram will be here. So see this q naught, it's my initial state. So first, so again I'm using here like 1 1 1 0 1 1, right? Okay, this will be very comfortable when you draw this. So when you see this 1, you have to convert it b, right? 1 is changed to b and you go for the right direction. 1, so this is b. And you go for the right direction, whatever it comes, it has to go for this right direction, which means whatever 0 or 1, 0 0. So when 0 comes, it has to 0 and rightward direction. So when 1 comes, it has to stay on it has 1 itself and go for the right direction. Okay, and it goes until b, right? So when it sees b, it is blank itself, and so when it sees B, it has go to left direction, so it have to go for left direction. So here it is Q2, right? So when you Q2 here, so we'll have this so it is on the leftmost direction. So when 1 comes, it has to change as blank symbol and it is go for the right direction, right? Okay, after that we'll have this again you go for the leftmost until B comes, right? So in between whatever things, for example, in between you have 0 or 1 comes, having the same symbols, 1 on 1 and go for the left, and 0 or 0 you go for the left. So this is Q3, right? So until have encountered B. So once you see this B, right, so you're going to backward direction. Whatever 0 and 1 comes, you're going to backward direction. If suppose B occurs, right, so you have to, for example, if blank is arrived, you have to go for the next one to be processed, which means you have to go for the Q0 state. Again you have to do the same operation. That's why you have to have the backtrack, and I'll have this right direction. So now this one is to be converted as blank symbol, and whatever 1 or 0, it has to go for the it has to say for the same state, which means Q1, until it go for the blank symbol. So once it is go for the blank symbol, you have to go for the left here. Why? Because already it is changed as blank, right? So now it has to change here, and now this is also be blank. Okay, now this is also be blank. So one is changed to be blank, and whatever 0 1 comes, it has to change or stay on the same state, and it go for the blank symbol. So again it is going for the Q0 state, initial state, and 1 is to be changed as B. Okay, so now we'll have this whatever 0 or 1 comes, it has to stay the same state, and after that until B comes, you have to go for the left. So B comes until you have to go for the left. So here also B and here also B, right? So when you have this, right, when you see this blank symbol, you go for the left one. So usually before the blank symbol, it has to be always 1. So 1 is again changed to blank symbol, but here 0 has occurred. So now the scenario will be right. So you have to change this 0 to 1, right? Either you have to go for left or right direction, and you stop here itself. This is known as Q4. So this is an acceptance state. So why? Because we'll have this 3, everything is blank, get blanks, and you'll have this 2, everything get blanks. So now in between you're having 0, so you have to make the 0 as 1, and my subtraction is done over here. Okay, so this is the way it has to be done. After this is the transition diagram for performing m greater than n. Okay, so if suppose my thing, right, so if m is less than or equal to n, so my module will be look like, see here, I'm telling you how this happened. 0 or B, 0 to change to blank space, and we'll have to go for the right direction, and we'll have this Q4. So this is Q5, this is Q4, and this is Q5, and here 1 is changed to be blank symbol, and just go for the right direction, and here blank is blank itself, and just go for the right direction, and we have this Q6, which is an acceptance state. So here this is known as, this is the part of, right, this is the part of m is less than or n. So how this will happen, right? So when you see this, here, if I'm having this 1 1 0 1 1 and 1, so here my case is this is 2 and this is 3, so m is less than or equal to n. So for this, my case to be proved as m minus n equal to 0 if m is less than or equal to n. So here m is 2 and n is 3. So here 1 is changed to be blank, so it is going to be go for the right direction. After that, until b comes, so when you see this b, you have to go for the left and make it as b, and again it is going for the leftward direction until b comes. Once it sees it as this 1 is changed to be b, okay, it is now again it is going to the forward direction until it encounters b. So once it sees this b, it has to be this 1 is changed to be, right? 1 is changed to b. Again it is going to backward direction until b comes. Once once the particular b comes, right, it has to go for the right direction, so which means you'll have this, right? So in this scenario we'll have to explain this. So once it is have 0 comes, right, after this b, it has to be this thing should be come as 1. So here 0 has occurred, so this 0 is replaced by b, okay, and it is go for the thing, the state q5, and whatever here 1, whatever 1 it comes, it has to make as blank only, right? So how many 1 it comes, it doesn't get bothering, it gets a blank symbol and go for the right direction. And again if it is a blank symbol, after that we'll have this blank symbol, it is going rightward direction. So now when you see this, right, so it is everything is blank, which means a 0. So everything blank, which means 0. So n minus n equal to 0. So this is the way it has to be proved, right? Okay, so now we are going to write a transition function. So transition function for this proper subtraction. So see here, so see this, look at this part and write this, right? Okay, del of q0 on 1 equal to, so del of q0 on 1, you have to go for q1, and 1 is replaced by b, and it is right direction. So q1, it is b and right direction. After that we will have this q1 on 0, and we are having two cases, and q1 on 1, so it stays on the same state, q1 0r and q1 1r, okay. After that we will have, see this q1 on b, it is going to q2, and the left direction, the state is q2 and b itself b. So q1 on b, q2 b leftwards. After that we will have this q2 on 0, q2 on 0, see here, when q2 on 0, right, when q2 on 0, we'll have this see here, so this is the direction q2 on 0. So when q2 on 0, it has to go for q4, and 0 is changed to 1, it is left direction, left or right direction, any one. And after that we'll have this q2 on 1, so it is going to be q3, and 1 is replaced by b, So after that we have Q3 on blank. So when you see Q3 on B, so it has to go for Q0 and the right direction. So Q0, B itself and right direction. After that, this is the addition part, right? So these are the addition part. We'll have this one and we'll have the subtraction part, right? So Q0 comma 0, we'll have this. So when you start with 1, it has to go for the addition operation. When it starts with 0, it is going for the subtraction operation. So Q0 on 0, we'll have this Q5, 0 be replaced as B, and you're having R. So we'll have this Q5 on 1. So Q5 itself, 1 is changed as blank symbol and right. So we'll have this Q5 on B. So just Q6 and blank symbol, and you're going for the right direction. Okay, now we'll see this transition using a sample string. On sample string. So now I'm going to write on subtraction operation. M is m minus n if m is greater than n, right? So we'll have to get right. So see here, Q0 1 1 1 0 1 1. So this is my input. So when you see this Q0 on 1, right? So Q0 on 1, we'll have this so we go for the right direction and state will be Q1, right? So that when we write here, see here 1 1 1 0 1 1. So 1 is changed to be blank symbol, and my tape fade will be Q0 is changed to this Q1, right? So now my input is B Q1 1. So this is the way it has to be, right? B Q1 1 1 0 1 1. Okay, this is the way it has to be written. So when you see here, when you go for the right direction, see here, when you go for the right direction, so the state is going to be right. The state is going to be written as in the right direction. So it is to be traversal on right side, and this the symbol will be going for the left one. So for example, see here when Q1 on 1, so now Q1 on 1, so when Q1 on 1, it has to be stay on the same state and go for the right direction. So Q1 itself, right? So B, it has to go for the right one. So that's why you have to move this 1 over here, and Q1 1 0 1 1. It's easy only. After that, again we'll have this 1, right? So Q1 on 1, Q1 on 1, again the same state. So it has to move for the right one. So 1, this 1 is to be changed here, and we'll have this Q1 0 1 1. Again Q1 0. So when 0 is occurred, it is also be. So see here, whatever 0 or 1 comes, it has to be changed. So it has to be say on the same state and go for the right direction. So B 1 1. So we'll have this 0 Q1 1 1. After that we'll have B 1 1 0. We'll have Q1 on 1. So when you see this Q1 on 1, again it has to be right. So it has to be changed. So I have to write multiple moves in the same part. So 1 1, so Q1B. Okay, so whatever the thing, so I'm coming here, right? So Q1B. So multiple moves I have made in a single step. That's why I'm putting a star over here. So Q1, instead of moving single move, I have to move because all are single move and on the same direction. That's why I'm writing in an using an asterisk. This is known as multiple moves. So B 1 1 0 1. So here also until B, right? So here Q1. So B is 1 1 0 1 1 Q1B. Okay, so this is the way I have moving over here. Okay, fine. When you see this one, when you see this Q1 on B, right? So when you see this Q1 on B, so it has to go for the left one, right? So it has to go for the left one. So this, when you see this leftmost direction, so Q1 on B, it has to change the state as Q2 and you have to move leftwards. So left side I have to change this B 1 1 0 1. So I have to move this Q2. So Q1 is changed to Q2 and I'll have this 1. The blank symbol is as it is, blank symbol. So Q2 on 1. Okay, so when you have this, right, I'm just deleting this blank symbol. Okay. So now we will have this Q2 on 1. So when you see this Q2 on 1, right? So whatever thing Q2 on 1, you have to change this state as Q3 and have to change this 1 as B. So have to go for the left one, right? So B 1 1 0. So this one has to be changed, right? So this is going to Q3 and 1. This is here B, right? So see here, when you not understand like this, right? So 1 1 0 1 1. So already it has changed as B. So when you go for this until B, it has to be stay here Q1 only. So when you have this, right, it has to change as Q2. So Q2 1. So when you see this Q2 1, it has to this 1 is changed to be blank, right? So this one is changed to be blank. So that's why blank at move it to the left direction. So this is now Q2 is over here. So B 1 1 0 Q2 1B. So that is why it is available here. So this is the way it has to be processed. So see here the other moves. B1 Q3 B11. So B110 Q31B, B11 Q301B, and we'll have this B1 Q3101B. This B Q31101B. After that we have Q3B1101B. Next Q20BB, and we have this BB, which means we have this Q4, right? Q4 B1 BB. So this Q4 is acceptance. So I'm writing here for m minus n if m is greater than n. So this, hence the proof, right? Hence the subtraction is done. Why? Because 1 is, so 3 minus 2 will be your 1. So that 1 is performed here. So hence the proof. So this is the way it has to be done. Thank you.